Good morning to one and all. I am Vadarevu Soni, in charge and assistant professor from Department of Home Science. Today, on the topic of food science and nutrition, we are going to discuss the death of cereals. In cereals, we are going to discuss about the milling process of wheat, the wheat products and gluten formation, and what are the various factors affecting gluten formation and the byproducts. Let's go into detail of milling process. So, coming to milling of wheat, let's know what is milling. Milling is a process of grinding wheat grains to produce flour. The goal is to separate the bran, germ, and endosperm efficiently while maintaining nutritional and functional properties. There are many methods of milling, but the modern wheat milling involves several stages to ensure high quality flour production. If you see a if you see the flow chart, you have many mechanisms like the first steps are cleaning, conditioning, grinding, sieving, reduction, fortification, and packaging and storage. So let's go into details of each individual. So the first step is cleaning. Again, in cleaning, you have different parts like magnetic separators, aspirators, rotatory separators, destoners, and scorers. So let's go into detail of cleaning. So before milling, wheat grains are cleaned to remove impurities such as dust, stone, straw, wheat seeds, and metal fragments. The magnetic separator, which is mainly used to remove metal particles, the aspirator is mainly used to remove light materials like dust and chaff. The rotatory separators, which is mainly used to eliminate large and small impurities. These toners to remove stone based on density differences, and scorers are mainly for the brush grains to remove dirt from the surfaces. So this is about the cleaning method. Now coming to the second step is conditioning, which is meaning tempering, mainly adding of moisture. It mainly moistens the grains by addition of 14 to 60% of moisture to toughen the bran and to soften the endosperm. This process involves the separation of bran from the endosperm. The wheat is allowed to rest for several hours, at least up to 24 hours, which means one day. The next step is grinding, which means breaking process. The wheat is passed through the roller mills to break it down into smaller particles. The first set of rollers that are called as break rollers, which separates the bran, germ, and endosperm. The endosperm is then reduced into coarse particles. For example, you know semolina, right? Then the next step is sieving, which means purification process. The ground wheat passes through shifter and purifiers to separate different particle size. Purifier uses air currents and sieves to remove bran and germ, which leaving refined endosperm. Later, the step is reduction, which means grinding into flour. The purified endosperm particles are grounded further into smooth and reduction rollers using smooth and reduction rollers. This process produces fine wheat flour. The flour is classified based on its ash content, which has a higher ash means more bran particles. The next step is fortification. It is optional if it is required or not. Every step doesn't require fortification depending upon your choice. Some meals add nutrients like iron, folic acid, and vitamin B complexes to enrich the flour. This is mandatory in some countries for public health benefits. Packaging and storage, which is the final product. The final flour is packed into bulk bags or small retail packets. Proper storage condition prevents infestation and moisture absorption. Next, we are going to talk about the various types of wheat flour produced. There are different types of wheat flour which are obtained based on milling and refining processes. If you see this, we're going to discuss about the whole wheat flour, brown flour, white flour, semolina, and cake flour. So let's go into details of each. Coming to the whole wheat flour, which has the extraction rate of 100%, which contains bran, germ, and endosperm, which are rich in fiber and vitamins and minerals. Mainly, it is used for nutritious bread, chapati, and baked goods. Next, coming to the brown bread, the extraction rate is 85 to 90%, which contains some bran and germ with more nutrients than white flour. It retains some bran and germ, making it more nutritious than white flour. Higher fiber and nutritional value than refined flour, commonly used for brown bread and whole grain pastries. Next is white flour, which has the extraction rate of 70 to 75%. It is mainly refined flour, mostly starch from the endosperm, lacks bran and germ, making it softer but lower in fiber. Used for bread, cakes, and pastries. Next is semolina, which has 60 to 70% of extraction rate. It is mainly coarse, purified wheat used in pastas and desserts. High in gluten, giving a firm texture, used for pastas, then some desserts. Last is cake flour, which has 40 to 50% of extraction rate. It is low in protein, finely milled for soft texture in baking, creates light and fluffy baked goods, ideal for cakes, cupcakes, and delicate pastries. So you can say the key points to this is high extraction rates means more fiber and nutrients. Low extraction rates refer to finer texture but less nutrients. Various based on baking needs and textural requirements. Finally, you're going to say that bran has mainly used for various products like used in animal feed, fiber, supplement, and breakfast cereal. And the germ which has been extracted is used for extraction of wheat germ oil, which is very rich in vitamin E and essential fatty acids, and middlings, which is used in cereals and animal feed. Now, coming to the gluten formation. So, let's know what is gluten. So, it is a protein network formed when wheat flour is mixed with water and kneaded. It gives dough elasticity, strength, structure, making it essential in baking. So, in preparation of gluten, there are two components. One is components of gluten and the process of gluten formation. In components of gluten, if you see, gluten is made up of two main proteins which are found in wheat. One is gliadin and second one is glutenin. In gliadin, it provides extensibility, which means stretchiness, and glutenin, it provides elasticity, which is firmness. These proteins absorb water and interact to create a viscoelastic network, trapping air bubbles during fermentation. Next, coming to the process of gluten formation, there are three steps, that is hydration, kneading, and resting. Hydration is water addition, which means when water is added to flour, gliadin and gluten, which are the main protein, absorbs water and began to bind. The amount of water affects gluten development depends upon if you add less water, the texture will be very dense, means tight gluten network is formed. When you add more water, where you have a softer texture, but your gluten is weakened. Next, the second step is kneading, which is a mechanical action. Kneading stretches and aligns the gluten protein into a long elastic strands. The more kneading, the stronger and more developed a gluten network becomes. Inefficient or insufficient kneading results in weak dough that cannot hold shape. And the final process is resting, which means gluten relaxation. After kneading, the dough is allowed to rest, allowing the gluten strands to relax. This prevents excessive toughness and make roller or shaping easier. Right. And the last one is factors which are affecting gluten formation. There are various factors where the gluten get affected. In that, some of the factors we are going to list out is flour type, water content, kneading time, salt, fat, which can be butter, oil, or shortening, sugar, the alkaline, and pH. So let's go into details of each. So, gluten formation, as we said, it depends on several factors. It also influences the strength, elasticity, and extensibility. So, let's talk about the different types of flours. As we said, high protein flour, that is bread flour, forms a strong gluten, and low protein flour, that is for cake flour, forms a weak gluten. The bread flour, which has 12 to 14% of protein, which has high gluten strength, which is mainly used for bread and pizza, and cake flour, which has 79% of protein content, which has a low gluten content, mainly used for cakes and pastries. Now coming to the second point is water content. More water helps gluten formation. Too much makes the dough sticky. So if you add adequate water, there will be a proper hydration of gliadin and glutenin for gluten network formation. Too little of water, incomplete gluten formation, leading to a crumbly texture, and too much of water weakens gluten structure and making the dough sticky and slack. Now coming to the kneading time, more the kneading time strengthens gluten, over kneading can break it down. So it is also called as mechanical action, increasing of gluten strength by aligning and bonding protein strands. Over kneading can break gluten strands, making the dough too tight and tough. Under kneading may result in a weak gluten network, leading to a poor dough structure. Now coming to salt, salt strengthens gluten structure and improves dough elasticity. It also improves dough elasticity and texture by tightening protein bound. Enhances dough ability to hold gas, improves the volume. Next is fat. Fat coats gluten protein, reducing gluten development. Results in shorter gluten strands, making the dough tender, mainly used in cakes and cookies. Higher fat content leads to a soft and crumbly texture. Next is sugar, which is a competes with gluten proteins for water, slowing down the gluten development. Important in sweet doughs. Okay, in sweet doughs, sugar makes the dough softer and less elastic. And next, coming to the acidity, if it's not mentioned here, acidity also weakens gluten and making the dough softer, and allowing time, that is resting time, allows the gluten to relax more and improve the extensibility. So these are some of the main important things. And for acidity and pH values, if you add lemon juice, vinegar, yogurt, it weakens the gluten, making the dough very softer. And alkaline conditions like adding baking soda make tough gluten. And resting time, that is for fermentation or autolysis, short resting time means gluten remains tight, making the dough difficult to shape, and long resting time allows gluten to relax, making the dough more extensible, used in pizzas and artisan breads. So this is the most important glutens in baking. Bread flour is mostly used for bread and pizzas. All-purpose flour is mainly for the cookies and muffins, and cake flour is mostly is used for cakes and pastry. With this, we can conclude saying that the milling process is a multi-stage process designed to separate and refine the wheat kernel efficiently. The final products varies in texture, color, nutritional content depending on the milling degree, and other things like gluten formation also plays a major role of the elasticity and making your chapati or any kind of a bread more softer in texture. With this, we're going to conclude that today our topic is about the milling process and gluten formation. In next class, we are going to discuss about the different modes of dextrinization, gelatinization, and the various topics we can discuss. Thank you. Thank you, one and all.